Once again, this one didn't have mailbag on the outside, so I opened it and it was obviously a mailbag. We're looking at the SeeBlocks build circuits like puzzles. Wow, this is something that I don't know if it's it's not a fail. It's not a fail, mate.
I didn't press any buttons.
SeeBlocks is for anyone eager to earn electronics. High school children, well, that's not you because you're only in kindy. Not even Sagan's in high school, but Sagan can definitely do this. So that might be a school holiday activity. SeeBlocks, awesome. So I might have a second channel video on that. Of potentially Sagan, even if Huxley, if he wants to have a go, we would love for you to have a look at our cool innovation to make circuit building as easy as building puzzles. Also included some talking points on the no, I don't do talking points. I do my own talking points. Thank you very much. You opened it. Excellent. Yeah, companies, if you don't know, they do if a company sponsor I don't accept sponsorships. Never have, never will. And if you take a sponsorship, Hux, from a company, then they give you talking points that you're supposed to, that come directly from their PR department, who have absolutely no clue, their marketing department, who have absolutely no clue at all. And yeah, they just know. I don't do talking points. Oh, look at this, Hux. Look. Wow. Look, it's got little individual elements and they've each got... Focus, you mongrel. There we go. They've got little... I'll show you up close in a minute, but they've got little... what are they? Little, almost like nuts. Are they nuts? Yeah, they're nuts. I think they're embedded nuts. Nuts embedded. So that's got that's an electrolytic capacitor on the board. Got a little matrix board. So all little components that you screw together. I assume that you screw them together. Oh, look, they've already built one, Hux. Look. There's a base. Oh, okay. No, you don't screw them together. They go into a little plastic base like that. That's novel. I wonder what the interconnect, if you have any problems with the interconnects with that, but they've obviously built that. You can see the schematic. I like how the schematic is on there like that, and you physically build up the schematic. That's really quite nice. I like that.
It's not a fail.
That's not a fail, Huxley. No, you're right. That is definitely not a fail. That's a thumbs up. Yeah? But it's all about the documentation and stuff like that that comes with it. So I assume that they got online website, YouTube channel, SeeBlocks. Oh, I've got my own login as well. Do I get private videos or something? A password. Okay, it looks like when you get it. Yeah.
Getting the next package.
Next package. Oh, he's so excited to get the next package. Anyway, that's very cool. Thank you very much. I'll show you a close-up of that, and then we'll have get the demo one working, and then we'll maybe have a second channel video of Sagan trying to assemble some circuits or something like that. All right, Sagan, let's check it out. They've got an online thing. We've logged in with our username and password.
Which I have no idea what it is.
You have no idea what it is. Yeah, it's a random thing. Your new dashboard has many features to help you access the important information. Next. This is the tour that we can go to. Timeline shows important upcoming events, activities, next week, month, further. So I guess they release new courses and activities and stuff. And recently accessed courses.
Don't have anything.
Nope.
This is our first time on it, obviously.
Correct, obviously.
Obviously.
The recently accessed courses block shows the courses you last visited, yep. And the course overview block shows courses that you are enrolled in, Kit 1. You can choose to show courses concurrently. There are 3 kits apparently. The next one is like electromagnetism. And after that, and there's a digital one too, apparently. Starring and hiding courses next. So this is the tour, because you won't be able to see this unless you actually pay for it. So end of tour. Thank you very much. End tour. So do it yourself. Oh, EE Fundamentals, 0% complete. Kit 1 is the one we have. So yeah, Kit 1 version 2. There it is.
Lots of different blocks.
Lots of different blocks in there. Getting started with SeeBlocks. EE Fundamentals. Let's go getting started with SeeBlocks, shall we? Okay, new messaging feature. Yeah, end tour. Okay, wow, getting started. Introducing the SeeBlocks, opening the blocks and getting started. Video, build your first SeeBlocks. Doing measurements, how to use a multimeter. Wow.
I know how to use a multimeter.
But some people don't. That's why they have
Yeah.
these. That's why they have these. So introducing the SeeBlocks.
In the fields of electronic or electrical engineering, we tell you building working
Speed it up.
circuits as experiments is one of the challenging things to overcome, especially when you're new. For example, this is what a symbolic circuit diagram looks like in a handbook. And this is the real working implementation of that circuit. As you can see, there's absolutely no resemblance between the two. For example, there's the transistor in this circuit, and that little black thing over there is the transistor over here. They don't look anything like each other.
Correct.
And this is the way prototype circuits have been done for the past 50 years or more.
Well, not really.
They
have
also
been
have another challenge in that they
overlay
make
ones.
intermittent contact. Sometimes you have a circuit and it looks like it should work, but below the plastic, they actually don't make electrical contact.
There are spring-based ones
So
where you put the circuits
we've
over and you have the
invented
springs
a system
follow the
to
circuit.
improve that and make it a lot easier to build circuits. We call it the SeeBlocks. And what we have here is a baseboard with magnets, and then
Yep.
you have individual component blocks. And on the top, you have the symbolic representation, the symbol
do
of
like
that
it.
component, and at the back you have the actual component. And I'm going to, in this board, I have my battery power coming in there, then a LED, and I'm going to connect this resistor over here. In fact, let me take the 500 light dependent resistor, for
Series.
example. And
Series.
then as I put my finger over it, cover it with my finger, the current through the LED changes. Also, this system is expandable. You get as many baseboards as you want, and they simply slide
pretty
next to each
jazzy.
other like this, and
Oh, they just snap.
And they
you can
just
connect, you can
snap
build
in.
expand your circuit that way.
The only problem I have with this, Sagan, the only
Yeah.
problem I foresee,
Yeah.
okay,
That they're very delicate.
very delicate, like if you've got ones that are, like we've got our example one here, which is split in half. The only problem I have with this is that will be the contacts. They're using the little nuts on the back.
Oh,
Okay,
yeah.
those using little nuts.
Nuts and magnets.
Nuts attracted to the magnets to make the contacts. And I suspect those contacts won't be that terrific. So I would expect in a kit like this to have more contact issues than, say, a spring terminal kit. That would be my guess anyway. That remains to be seen in practice, though.
Remains to be seen.
Remains to be seen. So they've already built one up for us. So as you can see, it's a light detector. We've got an LDR with a touch.
Touchpad.
We've got an LDR with a adjustment control pot to set the threshold, and a touchpad overlay there. Touchpad override to do that. My only other criticism, I guess, would be the white. I'm not a fan of the black on white. I know they want to make it look like paper, but I would have liked to have seen what it would look like with, say, a nice, just a PCB background, actually, just like a blank etched
Green?
piece, like fiberglass, or a green, or any other, color. I'm not a fan of the black on white, but I can see why they did that. I just think it would have maybe stood out more if they had the white was the like it was inverse, like the white was the circuit and the background was like a darker color. That would have been like, and it'd probably get less dirty perhaps, and I don't know. It's just it'd be interesting to experiment with different colors with that, I think. Okay, so you want to try and get this one up and running?
Yeah.
Well, what else have we got in here? Let's have a look. So there you go. It just ticks you off step by step as you go through. Is that cool, Sagan? Yeah, you like going through like courses like that where they're ticked off? Is that a good thing?
As long as it's a coding course.
As long as it's a coding course. But so courses that have like
Yeah.
ticks as you go through
Yeah.
are good, because
Yeah.
then you know you've done them.
Yeah.
Cool. All right, opening the box and getting started.
We've already opened
And we've
the
already
box.
opened it. I don't think we need that. Build your first SeeBlocks circuit. Example. Attempt quiz. Oh, grading method. Oh, we're going to get graded.
Oh, what?
Attempt quiz now.
Uh,
Uh-oh. Now, Oh, build the...
Build the circuit board.
Oh, okay. We've got to build the circuit below. Okay, we have to build it up. All right. We really needed an extra platform here. Can you find a lead? Or do we have the only lead in our existing circuit?
I think we might. Oh, button.
Yeah, there's buttons. There's buzzers and there's all sorts of stuff. Yeah,
Matrix.
Matrix. Yeah, a little matrix board. 1K resistor. There we go. Found a red lead.
So take this.
Yeah, we're actually going to have to disable. Let's just take this off. Okay. Let's use these ones down here. Okay, build it up. Well, no, see, because there's no physical connection on the schematic, is there? Goes there. Yep.
Oh, there's a connection.
Yeah, no. See, there's not. See, it doesn't come through.
Oh, yeah.
See?
I keep forgetting that.
That's really quite cool. And that one there's okay because it's not connected. There's no loop. There's no circuit loop, right?
No.
Yep. We need a battery, dude. All right, plug her in, Sagan.
We need to answer the question. Does the LED come on?
Does the do you think it will? Maybe. Ta-da!
Yes.
It comes on. So why does the LED come on, Sagan?
Because it's an integrated circuit. It goes around, then the power transmits through here, battery gives it power in here, flows through here, through the 1K, and then through the LED, and the 1K gives it enough power to light up the LED.
Well, it does. The 1K limits the current through, because if we didn't have that 1K resistor there, then the LED would draw a lot of power and we'd probably blow it up. Yeah? Because LEDs are current-driven devices. So we have to limit the current with a resistor, because that's what resistors do, don't they?
Yeah.
They limit current. Cool. So that works.
Yes. So that means... Oh, look, I don't even need to
Okay,
connect
if you
it.
leave that connected,
Yep.
I just want to give these a wiggle. Yeah, see? I want to I just have to put
One finger.
a slight bit of pressure, and
just
it
goes.
could, that is my fear. Yeah, see, look, that's my fear with this kit, is that those steel nuts with the magnets is not going to be the world's best. Those contacts are going to get pretty grubby too, so that's, So, but that's good, because if your circuit fails, then you get to troubleshoot it, don't you, Sagan? True. All right. Oh, we're on the wrong screen. You're on the screen capture screen. Cool. Check.
Where's the fail button?
The fail button. That's all right.
Need it.
Correct. Marks for this submission: 1.00 out of 1.00. Finish attempt. That was it. Time taken, 10 minutes. It's timing us. Oh, we had to go get stuff, and we set up a camera and everything. We set up a secondary camera, didn't we, Sagan? Yeah.
So, it could have taken us a minute.
That wouldn't take long at all. So, of course, that circuit was going to work. Yeah. But it did show up a potential issue. There we go. Potential issue. Just a little... Oh, no, it's solid now. But you saw it before. It was wiggling around and... Yeah. All right, so how do we finish review, I guess?
Oh, there we go.
Navigation could be slightly better, but build your first SeeBlocks circuit. Video, we've already done. Is that the one that we got? Yep, that's the one that we got. So we've already done that. No worries. Junctions versus crosses. Oh, yes, some of them are going to be junctions and some will be crosses. Let me see if I can find one.
Yeah, I saw lots of
Yeah,
them.
there you go. Here's the difference. Which one's a junction, Sagan? Which one's going to be a junction, you think?
It's a junction, that one, because it's got a circle in the middle.
That's
and
right.
Correct.
Yeah.
But this one, they don't connect. They just go across each other.
That's
They
right.
don't actually connect.
They don't actually connect. So this is a good example why you shouldn't actually use junctions like that. It should be like a right angle coming off. It should be, like it's good practice in industry not to do four-way junctions like that, because you can often, if you just glance at that, it's hard to tell, if it's connected or not. So
you just need to see the surf.
Yeah. So it'd be better if it was, actually showed you like a angled junction like that, so it's obvious. But a lot of people do schematics like that. And, well, that is your traditional way to do schematics. So how about we put in a buzzer? You want to put in a buzzer?
Yeah, buzzer.
Buzzer?
Bzz, bzz. Series
Want to take it out? You want to whack in a buzzer?
first.
No, it's okay. You can leave it like that. We'll put a one. We'll keep our 1K in series.
This way?
Yeah. Oh, no, that's back to front.
Oh, sorry.
Oh, we can just hear it. It's quite faint. The 1K is going to be limiting that. There you go. It's buzzing.
Sounds like it's in another part of the building.
It does, doesn't it? It's weird. Yeah, it's very faint. It's very faint. So there you go. That's pretty cool.
Yeah, it did sound like it was in another part of the building.
I just killed my mouse.
Your
Kill-
pet moose.
Killed my moose.
You killed your pet moose. I wonder what else we can put in there.
Well, anything that works in series.
Yeah.
That's current driven.
What else is in there?
No, I don't think we really have anything else. LEDs and, you know, we've made light and we've made sound, so that's pretty good. All right, so let's get rid of that. And let's use the circuit that we originally had, yeah? Actually, let's just do it like this. Okay, so plug the battery into there. This is going to be our light sensor.
That one.
That is the LDR. It's called an LDR, a light dependent resistor. So you see the symbol
Yeah.
is just like a resistor.
Yeah,
Okay.
except it's, yes.
Yeah.
Oh, 5K, 10K resistor. 5K.
Yeah, so we've got a 10K and a 5K in series. Actually, they've got this example here, haven't they? Didn't we see it? They go into voltage and current regulators, doing measurements, how to use a multimeter.
We know how to use a multimeter.
One thing we haven't seen in this, it's told us how to like build up circuits. So we built our first circuit, which is cool, but it didn't really explain what a resistor is, did it?
Yeah.
Didn't explain what a resistor is, didn't explain what a LED is. No, don't know. Yeah, maybe it's in here and we've just skipped it. Build your first, how to use a oh no, sorry, yeah, this is where we have to go back and kit 1.
Oh, yeah.
You remember? We have to go to kit 1, yeah, because we're just getting started. Oh, okay, right. This is why it didn't tell us what a LED and a resistor is, because we were just getting started with SeeBlocks. So it was just telling us about the blocks, not about circuits. So EE fundamentals, this is the one we want. Okay, here it is. Electricity basics, electricity versus electronics, videos, atoms and electrons, fun facts about atoms.
Know that.
See, you don't have to know it, but we don't, I'm not a big fan of starting electronics with atoms and stuff. I'm not a fan of that. Electronics basics quiz, electronic components overview, engineering's and 3 pillars of electricity. Wow, do you want to know what the 3 pillars of electricity are? All the studies related to our physical world as part of the field of physics, and that includes all the engineering disciplines.
Voltage, current, and resistance.
Yep. Engineering is applying the knowledge of physics to solve problems, but before you understand anything related to electricity, you must fully understand the 3 pillars of electricity: voltage, current, and resistance. And
That's what they were. I've learned about them before.
where did you learn that? Was it at school?
Yeah, I think it was at school.
Wow. Okay. Voltage, current, and resistance. See, I've never really heard of it called the 3 pillars of electricity before. That's not something that I've really,
I've never heard of it like that.
No?
Yeah.
Okay. But you do know about voltage, current, and resistance. Yes, obviously. Obviously, dude.
Obviously.
Current. And I won't go through them all because this is their paid course, obviously. So we're just having fun fact. We can learn about Volta. He's the one who's the volt is named after. Yes, you know that. And minimum voltage, experiment voltage across the LEDs. Series and parallel. Yep, you need to know all that.
You need to know series and parallel.
Yep. Or here's learning about resistors. This looks pretty good. Voltage recount, conductors, fun fact. How does a multimeter measure resistance? Variable resistors. Identification, resistance markings and stuff like that. So we've got some photos of some real resistors down there. That could be better. We don't have that's pretty, that seems incomplete. There's no resistor color code. Oh, no, here we go. We go to through-hole resistors. There you go. Through-hole surface mount, that's pretty good. Okay, resistor color coding, there it is. Yep, you've got to go through step by step. Is this good, Sagan? We go through
Yeah.
step by step? I mean, we need to spend
Grace.
hours at this. We're obviously not going to do it properly. We're not going to do it justice. But that's that's the resistor color code, Sagan.
Yep. Grey 100.
That's the multiplier. Yep. 100 million.
100 million.
So that's our model. It's very rare that you get a grey multiplier. Resistor color code examples. There you go. Resistor color code quiz, attempt quiz, and all that sort of stuff. So this is pretty good. They've gone to a lot of effort here, haven't they, Sagan?
Yeah.
This is pretty comprehensive. This is what you want. So this is why I say, like, you buy the kit or whatever. It's not the kit. The kit is not what you're paying for. You're paying for all of the course material and stuff that comes with it. So obviously,
They put a lot of work.
they've put a lot of work. There's a lot of effort that's gone into this. So hats off. So that it all looks pretty good. Ohm's Law Explained. We'll just have a look at their Ohm's Law Explained video very quickly.
Turn that up.
Ohm's law. You've learned that voltage is the potential of electrons to do work. Or, said another way, it's the pressure behind the electrons pushing them through a wire or electronic component. You've also learned that current is the flow of electrical charge across a surface, or the number of electrons flowing past a point per second. Current flow happens when there is a voltage difference between 2 points, and a path is created for electrons to flow. Such a path can be created by connecting them with a wire. The electrons will flow from where there's an abundance of electrons to where there's a shortage of them. And you've learned that resistance is the property of any material or electronic component to resist the flow of electrons from one point to another. A piece of wire with a resistance of 0 ohms will offer no resistance to the electrons that flow from high density, the negative pole, to low density, the positive pole.
Oh, they're doing negative
In this
electron flow.
scenario, all the electrons will
Electron
flow
current
between the
flow.
points almost instantaneously,
joke of my
and
audience.
thus the battery will be drained just as fast. Similarly, if you connect the 2 points with a resistor that has a very high resistance value, it will resist the flow of electrons, and thus it will take a very long time for all the electrons in negative to flow through the resistor to positive. The resistor actually limits the amount of electrons that can flow through it. The amount of electrons that make it through the resistor is also affected by the voltage difference between the 2 points, pushing it through. This means a higher voltage across the resistor will force more electrons through it than a lower voltage across the same resistor. Voltage, current, and resistance have a direct influence on each other. This relationship between V, I, and R is called Ohm's law, named after George Ohm, who discovered it. Ohm's law is one of the most
Looks a bit
important
grumpy, doesn't he?
concepts to understand in electronics. It works as follows.
A little.
If you know the current and resistance of a component, you can calculate the voltage across the component by multiplying current with the resistance. If you know the resistance of the component and the voltage across the component, you can calculate the current through that component by dividing voltage by resistance. And if you know the current through a component and the voltage across it, then you can calculate the resistance of that component by dividing voltage by current. One can summarize
the
all
Ohm's
three
law
of the
triangle.
above formulas into this simple VIR triangle. To summarize, voltage
Here we go. This
measured
is
in
good.
volts is the force that pushes the electrons from
we go.
negative to positive. The higher the voltage of the battery, the more force there is behind the
There'll be a
electrons
little
pushing
man.
them.
Pulling them up in a sec.
The voltage across a resistor is a measure of the energy difference between electrons entering the resistor and those exiting the resistor. If you increase either the current through the resistor or the resistor's value, the voltage across it will also increase. Resistance,
There he
measured
is.
in ohms, is the amount of resistance with which the
Squeezing
particular conductor or component will resist the flow of electrons. Current,
he's stuck.
measured in amps, is the amount of electrons actually flowing past a point in the resistor. If you increase the voltage across a resistor, you increase the energy or force pushing electrons through, and as a result, the current will increase.
Sagan's lost it. Is that funny?
Yes, very.
Poor little electron, dude. Poor Poor little
However,
electron
if
dude.
you increase the resistance of the resistor, it will require more energy for an
That's pretty
electron to
violent.
pass through it, and as a result, less electrons will flow through the resistor, effectively reducing the current through it. By changing any one of the three, you affect the others.
How would you rate that, Sagan? Was that good?
Out of 10, 8 out of 10.
8 out of 10? That was a pretty good introduction to Ohm's law. Yep, there you go. 8 out of 10. Well done. So I'll check out, because they'll have ones on like transistors and stuff like that. As I said, we're not going to go through everything here. We're just going to... All right, so we've had a look at our EE fundamentals. That looks pretty good. Looks like they've gone to a lot of effort there. And there's much more to it than what you see here. Let's go to our kit 1, yeah?
Yeah.
Do-it-yourself circuits for kit 1. Basic lead circuit. We've done that. Where's our... Wow, they got lots of different ones you can build up. Cascode transistors.
Oh, which one?
Where is it? The LDR with adjustable current with on touchpad. LDR with NPN on touchpad. Because we have that little transistor there, Sagan.
Yeah.
It's an NPN because the arrow is pointing outwards.
Up and out.
Up
and out.
The symbol's usually drawn like that, in that it's headed out. Yeah, the symbol's pointing out. If it was headed in, it would be PNP. But this is an NPN. So that's why we have to choose the NPN transistor with on touchpad. There it is there.
Red lead.
That's different to the one they had built up. That's different to the one they supplied. That's very different. So the one they supplied pre-built does not match the thing. Anyway, right?
It doesn't matter.
So this should do something. Hopefully, if we adjust that pot right, will this lead come on? So don't worry about our touch sensor yet. If we put our finger over that light sensor, look at that. Comes on.
Yeah.
Cool. See?
Wait. There we go.
And you can make it partially come on by allowing just a little bit of light through.
Oh, yeah, I can see
See?
it.
And that will change if we adjust our pot here, make it brighter. There we go. A touch sensor across there. So you build that up. Yeah, see? Oh, yeah. You've got to be careful when you snap them in to make sure they're getting good contact. That doesn't come on.
10K.
Got a 10K? Okay, you do need like something to help you get those out. Whacking a 10K. Let's get our crossover instead of a junction. There's a crossover. Whack it in.
Yep.
And
Told you it was a crossover.
there you go. It's a
told
crossover.
you.
So the one they gave us, the one they actually supplied was a little bit dodgy. And but the one that they supply and the one that matches their thing, if we put dark, it's still going to override, or light, it's still going to override like that. There you go.
I really want to make one using the
But see, the problem is
yeah.
that this will never. Yeah, the problem with this one that they've built is that the LDR does nothing. Actually, you don't need that. You can just have that open itself. You can take out, in fact, you can take out this 10K. So there you go, Sagan. There's our touch sensor. And we're playing around with an LDR.
I want to use the matrix.
Oh, the matrix. So you got to solder. Yeah, you got to solder components on there. They got a little...
Oh, yeah. I'm better at that than soldering, by the way.
You're better at me than soldering.
Yes, I am.
Oh, you are pretty good. Yeah. So, yeah, they've got a little matrix board so that you can solder components on. I wonder at what point in the course that you get up to that.
Probably
Anyway.
late. Very late in the course.
Yeah, I'd say so. Do they actually have soldering in here? Let's go have a look. Okay, so we've completed one of our circuits. Okay. So, but the LDR is not going to be doing anything there. Only 10%. Did they have soldering in there? I don't think so. Maybe we might need an advanced course for that. Yeah, we're just doing, EE fundamentals doesn't cover soldering. But that's okay. Nor should it. Because soldering's its own separate thing. All right. You want to build something else?
Yeah.
You
lost the kit.
I still haven't got a hold of this dashboard. So let's do our kit. What one do you want to build?
I'm not sure. There's too many choices.
Too many choices. Positive voltage clipper. Ah, M2 motor. Yeah. What? At M2. That looks like, I originally thought that was a motor symbol, but an M2 I don't know. Oh, meter. Meter 1 and meter 2, they're voltmeters. Okay, so they're measuring, you're actually using a multimeter to measure within there. So, what? An AC generator. I'm not getting that. Ah, that. Why, yeah, that is hand-drawn. That looks like a constant current.
Oh, look.
I'd say that's a constant current. Use this circuit above to produce... where's the oscillators and stuff? I'd like to see the transistors, like, build up oscillators and things like that. I don't think that is going to help anyone. No, I'm not seeing the value in that. See, the thing with these, Sagan, is that they give you the circuits, but they don't really give you anything to explain what's going on, do they?
They don't explain it.
They don't explain it. So you're building them up and the LED's coming on, but it doesn't really explain how this light-dependent resistor here affects, you know, the current sort of, you know, flowing through what's called the base of the transistor there. There's nothing. There's no explanation. Yeah, that would have been nice if there was. See, because I'm used to that. Like, you remember the 201, the 201 kit we built up?
Yeah, 201, yeah.
Yeah, it's got, like, explanations for each circuit, yeah?
Yeah.
So I think that would have been nice.
Yeah. I remember the one that Daddy accidentally didn't put a resistor in it, almost blew up.
What?
Yes!
What?
Yes, I remember that one. It almost blew up.
It did not.
Yes, it did.
Oh, I think you're exaggerating, dude.
It did.
You're exaggerating, mate.
Did.
But you remember how we had to troubleshoot?
Oh, yeah,
One?
troubleshoot.
Yeah, it didn't work, and then
Which
we
one
troubleshooted
was
it.
it?
That was a dodgy wire contact, wasn't it? It was the buzzer one.
Oh, yeah, the buzzer. Yeah, I think it was dodgy wire.
Video linked in down below. Yeah, I would have liked to have seen like each one of these accompanied with like just a 1 minute video, just a one minute explanation, like screen capture type video of like just moving the mouse around and saying, you know, like, or either drawing like an overlay saying the current flows through the base like this and stuff like that. Because just building up the circuit and having that LED come on,
Isn't really.
it's not that. It's not as educational as it could be, or is it?
It's not as exciting.
Not as exciting as it could be. Quick course feed. Oh, we could put quick course feed. We could add feedback. There you go. We can add feedback. Tell them that.
Every student. I'm not a student. Well, not
You
now. I'm on holiday.
You're on a holiday. You can be a student on holiday.
Yeah, I know.
With timed button. Ooh.
Time button.
Low current LED with time button. Ah, there you go. You want to add 100 microfarad cap in
that
there?
one.
Yep.
Got it.
Okay, let's build it in. Let's build it up.
We need
And
another.
it's a 3904 for those playing along at home. U stands for micro. U stands for micro. Is that the correct way? Because capacitors, electrolytic capacitors, are polarized. It's got a little positive on there. Yeah.
Yes, positive.
Yeah.
Upside down.
Oh, we're going to add our switch? Oh, I think, in fact, if we want to add our switch, I think we have to move everything along like this. Got a button? See, that one's not... Oh, that one. Fail. Wah. Our nut's missing.
Fail button.
The only button we have, the nut has fallen off. I don't know how they solder the nuts on there, actually.
Wait, I could do those better myself.
You think?
Yeah.
Wah, wah. Fail. Yep.
Fail.
That doesn't matter. We can use a link for a button. Okay, so put our 100 mic.
Here?
Make sure it's the right orientation. Because it doesn't matter which way around those two go, does it? Like, doesn't matter if that one's there and that one's there. Because series, it doesn't matter in series, does it?
Nope.
Hang on.
Oh, wait.
There, like that. And this is our dupe. We need another joiner. Oh, there we go. Got it. And we need two more, actually. Yeah, see, that one didn't snap in and make contact. So, ta-da! There's our circuit.
Okay.
Oh, it's on. Ready? Boom. And see how it only turns on for a short amount of time?
Yeah.
Because that is the capacitor
Yeah.
charging up. Yeah, that's the problem with this kit, is that it's a bit finicky. And the thing is, actually, troubleshooting a contact in here
It's very hard.
is not going to be the easiest thing to do.
Mix together.
Nuts and magnets, you think?
Yep. Or fire and hydrogen.
Fire and hydrogen?
Yep. It'll explode.
Hindenburg.
Yeah.
Yeah.
Mentos.
And Diet Coke.
Yeah.
Mentos and Diet Coke.
Never mix.
Oh, there we go. There we go.
Oh, yay. Yes.
Oh,
So dodgy.
oh, yeah. Oh,
More fails?
oh, yeah, more fails. Oh. But what do you think about the concept, Sagan? Is the concept good?
Yeah, the concept's good.
Yeah, concept's good. What else can they improve?
Probably the nuts and the magnets thing. The
Right.
nuts and the magnets, because that doesn't really work. I
Yeah,
could solder that better myself.
right. You could
Yes.
right. Or spring contacts
Yeah.
or
yeah.
something.
Spring contacts.
Yeah.
To the nuts and the magnets, big fail.
Fail. Nuts in the magnets. But that's their whole shtick.
Yeah.
That's their whole shtick.
It's working. Well, not fail, kind of.
Oh wow. Yeah. Nah, I'm not sold on this. Which is a shame because the courses are really quite good. Although, as I said, like there's no description. Like even just a text description, a video would be best because they've obviously put a lot of effort into their videos and stuff like that. So just shooting like a 30-second or 1-minute explainer video for each of these, I think would really complete it. Just like having like a highlighted tool or whatever to sort of like show current flow and direction and stuff like that. So it's fun to build up things and make LEDs turn on, but if you don't
You don't actually know.
if you don't know why, if they're not explaining why, yeah.
This is for lack of description. The fail button.
Critical feedback. Sagan only gives negative feedback. So we haven't gone through all this. I mean, just the introduction stuff I think is going to be worth your money.
Starting with atoms? Seriously?
Yeah, I wouldn't start with atoms. Although it's probably fun. Hang on. Let's have a look at their atoms and electrons video.
I know about atoms.
I do like their intro. It's quite nice. Nice and short. Atoms and electrons.
Atoms and electrons.
The
How does
voiceover's
electricity work at the smallest level? Everything we see in the world around us is made up of atoms. From the air we breathe, to the water in the oceans, to the sun and the stars. An atom is the smallest part of any particular material. If you take a drop of water and repeatedly divide it in half, eventually you'll end up with a single water molecule that consists of 3 atoms.
Hydrogen.
If you divide that water molecule further,
Works,
you will
eh?
have 3 individual atoms,
H2O.
1 oxygen and 2 hydrogen
H's and
atoms.
1A.
An atom is so small that there are about as many atoms in a single drop of water as there are water drops in all the
See,
oceans
this
of
is
the
good,
Earth.
but it's not.
Atoms consist of 3 smaller particles,
You know,
protons
yeah.
and neutrons at the core, and electrons spinning
Please let
around
us
the
know in the
core in
comments down
rather
below if
fixed
you're a fan
orbits.
of the electron first.
A proton
method,
has a
so to
positive
speak.
electrical
teaching
charge.
Electrons teaching
An
atoms
electron
first.
has an equal but negative electrical charge,
Some people
and
are.
neutrons have no charge. Neutrons are therefore electrically neutral. In nature, atoms will always try to balance out the number of their protons and electrons so that the atom as a whole has a neutral electrical charge. It is close to impossible to actually break an atom up any
See,
further
all we
into
want
its
to do
small
is
parts.
turn on the
But
flash
if
of
you manage
light
to
and
do
make a
it,
sound.
a
and
huge
teach us
amount of
about
energy is
atoms.
released, and you end up with 2 smaller atoms. These smaller atoms will have different properties than the original atom. You can, however, move the electrons of atoms around without affecting the properties of the atom itself. The fields of electrical and electronic engineering make use of that mobility of electrons to do work or carry information.
No, that's it. See, it didn't, Okay, yeah, it's nice. Nice video, but atoms and electrons, So they've got all their descriptions in here and stuff like that for all their things. They've got videos and descriptions. It's really nice, but then when you actually go down to the courses, you don't get any descriptions for your stuff. I mean, even a basic LED circuit, look, there's no description. So you think that could be useful to some people, Sagan?
To some people, yeah.
Yeah. So I do like the concept, but it's not as unique as they said in the original video, because there are, I think dating back to the 60s, please correct me if I'm wrong, there are the overlay sheets that you would have the schematics and you'd put over and you'd actually wire the components between the spring terminals, exactly like this. I do like the concept. I just think, yeah, the nuts on the magnets. Oh, just
Nuts, magnets, do
nuts,
not mix.
nuts and magnets don't mix. You just have the potential for too many dodgy joints in there. Is my feeling anyway. So anyway, links are down below. Thank you very much, SeeBlocks, for sending this in. They've obviously put a lot of effort into it, haven't they, Sagan?
They sure have. So no fail button for effort.
So yeah, I just hope they get maybe a more reliable method. I would like to see one big block, like when you join them like this, it just makes it kind of dodgy. I'd like to see like much
block.
larger sheets.
Maybe a 4 times block or
A
something.
at least 4 times that. Yeah,
time
at least 4 of those. 4 of those put together.
Yeah.
Large. Otherwise, yeah, it's just a bit wonky. Oh, is that 3D printed?
Yeah.
That's 3D printed. I didn't see that.
3D printed.
That's 3D
Can't
printed.
see
You can
that.
see the lines, can't you?
Yeah. If you can't see those lines, it is
Yeah.
3D printed.
3D printed. Okay, well, it's early stages in their campaign, because it costs a lot of money to get a plastic mold made for something like that.
Yeah.
So, I'm not even sure if you can. That might be, I don't know, molding experts out there. Tell us how easy would it be to get a mold for something like that made. This is why I think, Sagan, that they've made them small like this, because trying to 3D print a large item like that is not easy, because they warp and things. Yeah.
Where's our 3D printer in there?
MakerBot's right up. It's right up the top. It's all right.
Okay.
So yeah, so that's probably why. But anyway, that is a novel concept, and they've put a lot of effort into that.
Yeah.
So thumbs up for that. But did you have fun, Sagan? Yep.
Yep.
Cool. Did you learn anything?
Wait, I'd also like to point out, Daddy.
Yeah. What do you want to point out?
Underneath some of these components, the real things.
Yep. Are the actual components?
Yeah,
Yeah.
they actually fit into the gaps.
They do fit into the gaps. Yeah.
They actually fit in, so I think it was actually designed to be a matrix like that, so they could actually fit the components and.
Good observation, Sagan. They are, but I really like the concept. It's quite neat. But yeah, unfortunately, in practical implementation, it is a little bit dicky. But which I think it'd be nice if they had like a troubleshooting video in there or something.
Yeah, there are troubleshooting.
There are
videos.
were there troubleshooting videos?
Yeah, go into general. I think it's in.
Really?
Keep scrolling down. It was somewhere.
Think you saw a troubleshooting thing?
Yeah, troubleshooting with dodgy faults and
Really?
Yeah.
Yeah, because they definitely need things like that, just to let people aware that if your circuit doesn't work, it's probably not. It may not because you built it the wrong way. It may be because of the contacts and stuff. Cool. All right. Maybe it's in there somewhere. And we don't know.
Yeah, it's somewhere. I
Anyway.
definitely saw a troubleshooting.
Cool. All right, Sagan, did you have fun? Yep.
Yeah.
All right. Cool. Thanks, dude. All right. Say, catch you next time.
Catch you next time. Bye-bye.